Hello and welcome to everyone. My name is Dr. Supriya Gupta Bani, Assistant Professor of Computer Science and Engineering with Data Science branch from Ramdev Baba College of Engineering and Management. I am going to share you the discussion about watershed segmentation area and their techniques. That is the theme for today. So let's begin with the brief synopsis of the lecture that is broken into different outlines of watershed segmentation. Watershed segmentation is another part of digital image processing where we are going to use the segmentation algorithm to process the images to segment the objects. Now, what is the image segmentation? Image segmentation process of partition a digital image into multiple regions, sets of pixels, simply and simplify the changes representations of an image into something that is more meaningful and easier to analyze, typically used to locate objects or boundaries, lines, curves, etc. in the images. Now, what is watershed transformation? Image data may be interpreted as a topographic surface where the gradient image gray level represents altitude. Region edge corresponds to high watershed and low gradient region interiors correspond to catchment basins. Now, what is the procedure to apply this watershed based image segmentation? Catchment basin of the topological surface are homogeneous in the sense that all pixels belonging the same catchment basin and connected with the basin's region of minimum altitude gray level by a simple path of pixels that have monotonically decreasing altitude gray level along the path. Such catchment basins then represents the region of the segment image. Now, what is the watershed segment? Images can be detected from the image with segmented image that is basically based on the catchment basin and their minima or local minima we can find from that. The watershed is a classical algorithm used for segmentation, that is for separating different objects in an image. What is different object? That is calculatively appear in your input image. Starting from user defined markers in the watershed algorithm treats pixel values as a local topology, that is evaluation, and that elevation is going to use as local topology for the input image. The algorithm floats basin from the markers until basin's attributes to different marker meet on the watershed lines. In many cases, markers are chosen as local minima of the image from which basins are floated. In the example below, two overlapping circles are to be separated. To do so, one computes an image that is the distance to the background. The maxima of this distance, that is minima of the opposite of the distance, are chosen as markers and the floating of basins. From such markers separated the two circles along with the waterline or watershed line. Basically, what we are performing here in watershed segmentation, we are going to choose the basins or catchment basins from the image, and then we are applying this local minima line to that image to converting the overlapped image or touched image to separate them with a watershed line. Here we can see in the image two overlapping circles are there. we have to find the distance between these centroids, and then finally we are producing the local minima concepts for finding the line, watershed line for both the overlapped surfaces. When we find the local minima and the basins from these catchments and find out the watershed line for green for a single image and white for the another overlapped image. Now, what is the procedure to doing this algorithm is a classic algorithm used for segmentation and is specially useful when extracting, touching or overlapping objects in image, such as the coin in the figure above. We can see that the coins are overlapped. In such case, if the coins are touched with each other or overlapped with each other or some similar objects, we can see the pills, the coins, the another objects are overlapped to each other or touching the objects in the image can be separated with this watershed algorithm. Using traditional image processing method such as thresholding and contour detection, we would be unable to extract each individual coin from the image. But by leveraging the watershed algorithm, we are able to detect and extract the coin without a problem, because this basic traditional method cannot separate the objects by a watershed line, but the watershed algorithm provide the watershed lining for each and every overlapped, touched or separated objects. When utilizing the watershed algorithm, we must start with user defined markers. These markers can be either manually defined via point and click, or we can automatically or heuristically define them using methods such as thresholding and morphological operations. Based on these markers, the watershed algorithm treats pixel in our input image as local elevation called topology. The method flows valleys starting from the markers and moving outwards until the value of different marker meet each other. In the order of obtaining accurate watershed segmentation, the marker must be correctly placed. How to use the watershed algorithm segment and extract object in image that are both touching and overlapping. The accomplish this will using a variety of Python packages including SciPy, scikit-image and OpenCV. These all are the methods of Python packages where we can use the image segmentation using watershed algorithm. Here in this image we can see all the coins are touched with each other. So we are going to process this image segmentation with watershed image segmentation algorithm. In the above images, you can see example of objects that would be impossible to extract using simple thresholding and contour detection. Why we cannot extract the exact output or exact object from these methods? Because these are the typical basic methods that cannot provide us the watershed lining for each and every object. Since these objects are touching, overlapping or both, the contour extraction process would treat each group of touching object as a single object rather than multiple object. So that's why we cannot extract each and every coin as a single object or as another object, because these methods taking it as a single object. Now, what we understand the limitation of simple thresholding and contour detection, let's move on to the watershed algorithm. Open up a new file, name it watershade.py, as we have to see that we are going to take the name of a file is watershade.py because we are performing the watershed algorithm for this image, and insert the following code. Here is the code where we can generate or we can load the image into as the pixel form, and after loading the image we are going to apply this watershed image segmentation process for this image. We are going to apply this watershed algorithm in two manner. We have to find the markers for separating the images into the different parts, and second one, we have to find the local minima for the image segmentation, and again we have to separate the images into different objects. Again we will start on line number 2 to 8 by importing our required package. We will be using functions from SciPy, scikit image and imils and OpenCV. If you don't already have SciPy and scikit image installed on your system, you can use PIP to install them for you. This is the code for Watershed OpenCV, where PIP install by SciPy and scikit image and imils for you. Line number 11 to 14 handled praising our comment lined arguments. Just like in the previous example, we only need a single switch the path to the image. We are going to apply the watershed algorithm too. From there, lines 18 and 19 load our images from disk and apply pyramid mean shift filtering. Line 24 to 26 perform grayscale conversion and thresholding. Give our thresholded image, we can now apply the watershed algorithm. Now again from this code we have applied here the loaded images for going to introduce the watershed algorithm. Then we have the different type of Python libraries like SciPy and scikit images, and we are going to use this Python library to do the segmentation with the watershed algorithm. The first step in applying the watershed algorithm for segmentation is to compute the Euclidean distance transform. We can say it EDT via the distance from transform edit. Function line 32. As the name suggested, the function computes the Euclidean distance to the closest 0, that is background pixel. If we are set the closest 0 points, that could be identifier background pixels. For each of the foreground pixels, we can visualize the EDT in the figure below. Now you can find there the coins are arranged in the manner where we have defined the different coins in the different foreground and background images with their pixel values according to 0 to 255. That contains the RGB values and separated the images to one and another. We can find here the different types of coins arranged here in the same or similar manner. They are connected, they are overlapped, so we have to find their connections with this distance EDT, Euclidean distance transform. On line 33, we take D, our distance map, and find peak local maxima in the map. We will ensure that is at least a 20 pixel distance between each peak. Line 38 takes the output of the peak local maximum function and applies a connected component analysis using 8 connectivity. The output of this function gives us our markers, which will then feed into the watershed functions. On line number 39, since the watershed algorithm assumes our markers represents local minima, that is valleys in our distance map, we take the negative values of d. As we calculated the distance value d and the local minima valleys are basically the finding of pixels that contains the similar value, and the another valley can be detected as the similar values of the another valley. We can detect with these valleys or differentiate the objects from one to another, and we have to find a basic line between these two objects, whether they are overlapping, whether they are touched. The watershed function returns a matrix of label, a numpy array with the same width and height as our input image. Each pixel value as a unique label value, pixel that have the same label value belongs to the same object because the similar type of object having the same intensity of pixel values. The last step is to simplify loop over the unique label and the values to extract each of unique object. What is a unique object? The unique object means that you have to clarify that each coin is uniquely identified with this watershed algorithm. On line number 44, we start looping over each of the unique labels. If the label is 0, then we are examining the background components. So, we simply ignore it. Otherwise, line 52 and 53 allocate memory for our mask and set the pixels belonging to the current label to 255, that is white. We can see an example of such a mask below on the right. Here we can see in the images that the input image is given, the various coins are touched to each other and overlap to each other. Now we are converting here it with the watershed segmentation, and we can find each and every coin as a gray level values 255, that is white. Whenever we are taking the gray level values from 0 to 255, it means 0 considered as black and 255 considered as white. So, we are converting the images into 0 to 255, all coins are converted in the white pixel images, and now we are going to extract a single coin as a segmented image or segmented output. So, the watershed segment algorithm can clearly state that we could provide a single exact unique output or object with the watershed segmentation. On line number 56 to 59, we detect contour in the mask and extract the largest one. This contour will represent the outline boundary of a given object in the image. Finally, given the contour of the object, all we need to do is draw an enclosing circle boundaries surrounding the image object on line 62 to 65. We could also compute the bounding box of the object, apply a bitwise operation and extract each individual object as well. Finally, lines 68 and 69 display the output image to our screen. Now, in this image here, we can see the input image of coins overlapped and touched are given. Here, we cannot extract each and every coin as an object by the local thresholding or adaptive thresholding methods. So, the watershed algorithm is going to prove the importance of the segmentation here, and we are hence done the all algorithm process with the code and doing the all processes methods of watershed algorithm, that is detecting local minima, detecting valleys of a similar object, detecting similar type of objects, detecting distance from each object, detecting what is the background, that is background in a white and black images. Black image considers 0 points, 0 to 255 grayscale values. Now, In the final, markers are connected to each and every coins and finding the watershed lining that is shown as green. If you can see, each and every coin is covered by the green circles, green lines, that are the watershed lining that can detect your coins in different values. Now we have provided each coin with a different number because each coin has a different object. We can consider each coin as a different object with the watershed algorithm. So this is the beauty of the watershed algorithm, that we can define each and every object with the overlapped and connected objects. As you can see, we have successfully detected all 9 coins in the images. Furthermore, we have been able to cleanly draw the boundaries surroundings each coin as well. This is in the stark constraint. The previous example using simple thresholding and contour detection, whether only 2 objects were incorrectly detected. Now that our watershed p.py script is finished up, let's apply it with a few more images and investigate the results for the same code. We are only changes the images of coins, and now we have applied this again watershed algorithm for the next image, and we can find that yes, this is also given a beautiful results with the separating all the images with the green biomarkers or watershed markers line. We can see that each coin has detected as a different object with the watershed segmentation algorithm. So the watershed segmentation algorithm perform very beautifully for these type of images. Again, let's try another image, this time with overlapping coins. We can see the input image has the overlapping coins to each other, and the third one again has the overlapped coin with each other, and we have applied same code of watershed segmentation algorithm for this image. We can find that the output image is clearly showing each and another object is with the different line of shade green with watershed lining, and we can detect that each coin is different from the another. We cannot detect each and every coin with the thresholding and basic methods. So the watershed algorithm is totally different with the traditional methods, and it is showing a better and beautiful results for the overlapped and connected objects. In the following image, we have applied the watershed algorithms for giving pills. Now we can see that the input image of pills are connected to each other and overlapped to each other. So again, watershed algorithm is defined the different object in the form of numbering, and it gives a surrounding lines or extra lines for green effect, that each and every pills are different from each other. Here again the pills are overlapped, so the watershed algorithm is going to perform very well for this image, and we can see they all are detected individually by performing the watershed lining, that is green line or green surroundings for each pills. We can see the objects are detected separately. Visualize an image in 3D spatial coordinates and gray levels. In such a topological interpretation, there are 3 types of points. Points belonging to the regional minimum, points at which a drop of water would fall a single minimum, the catchment basin or watershed of the minimum, points at which a drop of water would be equally likely to fall the more than one minimum, the divide lines or watershed lines. Now here in the picture we can see the 3D image will be there. The 3D image, it means the 3 coordinates are there. So we have to find here 2 basic methods to find the watershed lines. First is the catchment basin and the second one is minimas. If we find two things, then the watershed lines could be clearly find out between these interseparated pixels. The objective is to find watershed lines. The idea is very simple. Suppose that a hole is punched in each regional minimum and that the entire topology is flooded from below by letting water rise through the holes at a uniform rate. When rising water is distinct, catchment basin is about to merge. A dam is built to prevent margins. These dam boundaries corresponding to the watershed lines. What does it mean? It means that these boundaries are going to do as a line of watershed line that can be detect that the basins are different from one and another. The similar type of pixels of one basin is totally different from the similar type of pixel of another basins. So, this watershed line can be differentiate these both separators as a basin and the different basins. Again, with this 3D image, we can see we have to do the foreground and background image analysis with the grayscale 0 to 255. 0 indicates black, 255 indicates white. So, the gray level values are considering the background and foreground images. Now, converting with the minima and converting with the catchment basin, we have to find the watershed lines with the markers, and after that we have to find which maxima is converting in the single type of construction basin. When we have decided the basins and we have decided the lines, watershed segmentation algorithm can detect these both basins and can clearly state that these objects are different from each other. Start with all pixels with the lowest possible values. These form the basics of initial watershed for each intensity level of K. For each group of pixels of intensity K, if adjacent to exactly one existing region, add these pixels to the region. Else, if adjacent to more than one existing region, mark as boundaries. Else, start a new region. Whenever we are trying to go with the watershed algorithm, we have to follow this algorithm where we are going to initialize the pixel with K and we find the adjacent exactly similar pixels with the connected basins. If we are going to find all the pixels are similar, it is find a single object. If we find the pixels are differentiated with the another basins, then we are going to provide that another regions are in form a image and find the last image with the different images. Else, if we are starting with the new region, we can find the watershed segmentation algorithm detected different type of object with these boundaries. In this algorithm, we can see the blurred image is there and watershed algorithm might be used on the gradient image instead of the original image. What is gradient image? We have to convert the images in the blurred image to remove the noisy image, and gradient blurred image we can see as an input image. Now, the input image is seeing as black and gray level values, where we can see the background is with the gray level and the black objects are as a foreground. Now, we have to apply the watershed algorithm with this blurred image or gradient image, and then the watershed algorithm defined the different basins from this algorithm with similar pixels quality. Now, the watershed algorithm provide a ground or surroundings watershed lines with white markers with white lines that could be detected that the objects are different with each other. Now, this is a noisy image with local regularities. So, the gradient over segmentation might occurrence. Here we can see that maximum type of objects are looking like a similar object, when we convert it in a gray level. So this is not fruitful for us to converting it gray, because all the objects are treated as noisy image or noisy objects. So we have to treat it as a watershed segmentation algorithm and provide it with a plain image as watershed segmentation algorithm. Now watershed segmentation allowed here that they will define the objects with the finding with local minima, with the basin clarity, with the regular impact of pixels for each other, and finding the watershed line or markers from that algorithm. Here we can see that the watershed algorithm going to do the solution to limit the number of region minima where marker to specify the only allowed regional minima. Here gray level values might be and uses as marker. We can use the gray level values as marker, and then we can find out all the objects with the foreground and background images, and the watershed algorithm has given the watershed line and markers with the help of global or local minima, and find it all the objects separately from image. This solution limit the number of regional minima as a marker to specify the only allowed regional minima. Here we can see the histogram plottation of local and global minima, where regional minima is approaching all the similar type of similar pixels with the given proper management, and it has given us a similar type of histogram for the similar type of pixels. What are the application for the basic watershed algorithm, that is medical imaging? What can be done in medical imaging with this watershed algorithm? For the CT image, for the MRI image, that is medical resonance image, and X-ray image where the objects are overlapped or touched to each other, we can separate the each and single object with this help of watershed algorithm. The second one is semiconductor technology, where we can find the different type of elements are connected to each other, and from this image we can apply the watershed algorithm to the semiconductor technology and finding out the semiconductors or elements from this watershed algorithm. Traffic monitoring. If we are going with traffic monitoring, we can see the object detections are there, and if the objects are overlapped or touched to each other, watershed algorithms can clearly define the traffic monitoring with the image segmentation. Face recognition. If the face recognition going with the watershed algorithm, the eyes, nose, each features of the faces can be detected separately with the watershed algorithm. Identifying features in steel, coffee, bean separations. This is the basic approach to decide which is coffee beans, which is steels, which is can separated this. So the watershed algorithm has beautifully applied with this and given the beautiful results to separate the images with the different objects. Now I am concluding the watershed segmentation algorithm with a new watershed transformation algorithm based on chain code. Complexity of the proposed algorithm is discussed with the given algorithm, and experimental results are shown to prove that the objects can be detected as separately with the given image. Now chain code is giving point of chain code is the direction code of that current pixel point to point in chain code is the directional code that neighbor pixels point to. Thank you.